Honorable teachers and respected staff, good afternoon to all of you. My name is Aryan Verma and I am a fourth year student of Civil Engineering, Faculty of Engineering and Technology, University of Lucknow, and I am here to give a seminar presentation on the topic tunneling techniques. So here I included what are tunneling techniques and type of tunneling techniques. A special method has a box checking method and micro tunnel method. Case study I included Atal tunnel, Jawahar tunnel, Pasig tunnel. So, tunneling techniques are the method by which we construct tunnel for a purpose. IS 15026-2002 is referred for tunneling method in rock masses. The tunneling technique is adopted by the following factors: geological and hydrological condition, cross-section and length of continuous tunnel, local experience and time cost consideration, limit of surface distribution and many other factors. Type of tunneling techniques: drill and blast, cut and cover, shield and tunneling boring machines, New Austrian tunneling method, special methods. Some tunneling method is based on the type of soil, hard soil and soft soil, as hard soil, full face method, heading and bench method, and drift method and pilot method is referred. Soft soil, four polling method, needle method, RV method, American method, English method, and Belgian method are preferred. Drill and blast method. This tunneling involves the use of explosive. Drilling rigs are used to drill blast holes on the proposed tunnel surface to a designated depth for blasting. Explosive and time detonator are then placed in the blast hole. Time detonators are used, which are delayed detonators. Once blasting is carried out, waste rock and soils are transported out of the tunnel before further blasting has to be done. These are the figure of drilling and blasting. Cut and cover method. It preferred at a shallow depth. The basic concept involves the digging of a trench. Tunnel box elements are installed, after which they are covered over to reinstate the surface by a support method. Common steps are following: installation of retaining wall, evacuation of installation of steel strut, construction of underground structure, backfilling and reinstatement. Construction of tunnel by the cut and cover method. These are the picture of work progress. Shield and tunnel boring machine. The shield tunneling method is a boring technique that consists of a shield, a protective metal cylinder, and drilling support mechanism. This is a trenchless method. A rotating cutting head is positioned at the front of the shield. The shield tunneling method may be done with drilling slurry tunnel before machine, or without earth pressure balance shield. During shield tunneling, to remove the soil from the borehole to the ground surface, these allow tunnel to be evacuated in a wide variety of ground conditions and beneath towns, cities, rivers, and even tall buildings. These are the components of tunnel boring machines. New Austrian tunneling method. The New Austrian tunneling method is a support method to stabilize the tunnel perimeter by means of sprayed concrete anchors and other support and use of monitoring to control stability. It is a method of modern tunneling design and construction of employing sophisticated monitoring to optimize various wall reinforcement. Technique based on the type of rock encountered as tunneling progress. Main ideas is used to geological stress of the surrounding rock mass to stabilize the tunnel itself. A general sequence of tunnel construction using New Austrian tunneling method is marking of drilling and drilling of holes, charging with explosive and blasting, mucking and installation of primary support, arrangement to prevent ingress of water, secondary support, and final lining. These are the components of New Austrian tunneling method. Special methods. Tunnel checking. It is a box checking, a pipe checking method in which non-disruptive method of installing utility tunnel and conduits by thrusting pipe through the ground as controlled evacuation is undertaken at the face. Its application into installed storm drains, pedestrian, for roadways, undercrossing, for livestock and wildlife in many industrial settings. Microtunneling, it is a tunnel construction technique used to construct utility tunnel from approximately 0.5 to 4 meter in a diameter. The microtunneling boring machine and jagging frames are set up in a shaft at the required depth. Some tunneling method is based on the type of soil, hard soil. First, full face method. The equipment is used like drilling, jumbo, a platform, road header, or evacuation, which have to reach the entire face. The machinery used for mud clearance in order to load a transport way. The minimum profile for economical driving is 5 meters square. It can be dangerous in rapidly changing or worsening rock condition and in case of water ingress over adaptability if mechanized. Second, heading and bench method. This method involves the driving the top portion of the tunnel in advance of the bottom portion in large tunnel, and when the quality of rock is not satisfactory and heading benching method is often used. Drift method. This method, after driving the drift, the drill hole are the drilled all round the drift in the entire cross section of the tunnel and filled with the explosive and ignited. The rock shatters, the muck are removed, and the tunnel expanded to the full cross section. Fourth, pilot method. A small tunnel is excavated over the entire length or over part of a large tunnel to explore ground condition and are to assist in final evacuation. In soft soil, tunneling methods are preferred. First, four-poling method. This is probably the only system advocated for running ground and similarly soil. This process is slow, time-consuming, and requires skilled manners. Following sewers, gas pipes, and ordinary depth could be constructed through this method. Needle beam method. This method is suitable for soil where the roof could be dependent upon to stand for some minutes without support. This method could be advanced by 10 to 12 length per day. The needle beam consists of a stout timber or a composite fleshed beam and forms the temporary primary support during the evacuation. Army method or case method. The United States Army devised this method for constructing a small tunnel at reasonably shallow depth. This was mainly used for laying underground sewers. The advantage of this method lies in its simplicity and economy as only a few timber planks with 1 to 2 trench shacks from the leading equipment. American method. This method is suitable for a large-sized railway or highway tunnel, a top drift driven and supported by lagging cap timber and parts, sides widened, wall plates introduced to a arc set then vertical post driven. Belgian method. This is a popular method and is suitable for all classes of moderately firm or hard soil. This started for the construction of a top heading propped approximately to the level of the spring of the arc of a horse-drawn tunnel. The heading was then extended to each side to permit construction for the upper part of the arc, which was extended by underpinning working from side headings. The site was only practicable where rock loads were not heavy. Case study about the Atal Tunnel. Atal Tunnel is also known as Rohtak Tunnel. The cost of the entire project is rupees 3200 crore and completed by PRO under Ministry of Defence. The foundation stone for the access road to the south portal of the tunnel was laid on 6 May 2002. The first blast took place in 2010 and the last blast took place in 2017. The tunnel was constructed using drill and blast and Natam technique, and chief engineer name is KP Purushottam from Kerala. The tunnel of 9.02 km long connects Manali to Lahore, Spiti Valley throughout the year. Earlier, the road remained impacted for about 6 months. every year owing to the snowfall. It reduced the road distance by 46 km between Manali and Leh, and the time is reduced 4 to 5 hours. It is a horse-toe shaped single tube double lane in with a roadway of 8 meters. It has an overhead clearance of 5.25 meters. It is 10.5 meter wide and has a 3.6 into 2.25 meters fine-proofing emergency egress tunnel built into the main tunnel itself. There are 18 egress tunnels where after every 500 meters there is opening up in case of emergency. It has the state-of-art electrochemical system including the semi-transverse ventilation system. The tunnel was ample safety features put up into it including telephone connections at every 150 meters for emergency communication, fire hydrant mechanism at every 60 meters. The breakthrough from the end was achieved on 15th October 2007. These are the Atal Tunnel, Jawahar Tunnel. It is also called as Panihar Tunnel, is a road tunnel in Indian Union Territory of Jammu and Kashmir. The length of tunnel is 2.85 km. The tunnel was constructed by Alfred Kunz and C. Barzal of Germany between 1954 and 1960. The tunnel was renovated by the Border Road Organization under the Biocon and its costs around the 75 to 80 crore rupee in 2016. The tunnel has been designed for traffic density 150 vehicles per day in each direction, but the number of vehicles is now 7,000 in both directions after its renovation. After renovation, the tunnel now has a two-way ventilation system, pollution and temperature sensors, lighting system, and with emergency phones for any assistant installed from Border Road Organization. Jawahar Tunnel, Parsik Tunnel. The Parsik Tunnel is a railway tunnel which is 1.31678 km long electrified dual line railway tunnel located in Parsik Hill in the east of Thane, Maharashtra. Its work began in 1906 and opened in 1916. The width of the tunnel is 10 meter and with a height of 6 meter. It is one of the oldest tunnels in India. Trains typically cross the tunnel in 2 minutes. The speed limit is 90 km per hour. The tunnel was electrified in the year 1925 with 1.5 kilovolt in 1925 and later it was electrified 1.5 kilovolt DC to 25 kilovolt Hertz AC overhead line by the Central Railway. This is the ingress in Parsik Tunnel. References. I have taken all the information from the various papers and various websites. So, Champan, D.N. Mense and A. Setrak, Introduction to Tunnel Construction, CRC Press 2010. And I have used Hiran R.J. Pithoda and J. Bhavasar, box checking as beneficial construction tool, problem and remedies. Papers. Thank you.